So what we have is an exact differential equation. So exact differential equation is usually in this form. So this dz is what makes it differential equation. And if you are solving differential equation, it means they want you to get the value of this z. So once you have differential equation in this form, the z is equal to p s plus p y, where p and q are functions of s and y. Then this dz is an exact differential equation if and only if and only if when you differentiate p partially with respect to y, the answer you get will be equal to the differentiation of q partially with respect to what else. So let's take one example. Example 1. If you are asked to check if the z, which is equal to s squared plus 2y ds plus 4ys dy. So your duty is to show, because the question is show that what we have is an exact differential equation. Show that the z is an exact differential equation. So how do you do that? Just to show. So if you want to show, you are going to now use this principle. So you see, you write solution. You write solution. So what do? Our p is the coefficient of the x. So coefficient of the x means anything that is in front of the x. So you now say, let our p be what? S squared plus 2y. And our q be what? The coefficient of the y, which is 4ys. So according to the instruction, what do? You differentiate p partially with respect to what? Y. So when you are differentiating partially, it means anything that is not y, you consider it to be constant. And differentiation of constant is 0. So this s now, we are considering it to be constant. So if you differentiate s squared, the answer will be 0. Now if you differentiate this now, 1 here is here now, 1 times 2 will give you 2, 1 minus 1 is 0. So your answer will be 2 times 1, because anything raised to power 0 is 1. So your answer is 2. So you also differentiate q partially with respect to x. So if you come here now, there is s here. So this 4y, you treat it as constant. So when you differentiate, what will it give you? So it's going to give you, what it's going to give you is this. It's going to give you what? When you differentiate this, it's going to give you 4 what? 1. So you now say since what? The p is not equal to the q. It's not equal to the q over the s. It is not an exact differential equation. But if the equation is like this, that will be our example 2. If the equation is like this, check whether the z, which is equal to s is equal to, if this one is now 2y squared, the x, then plus 4y s dy. And you are asked to check whether this one is exact differential. What do? In the same way, you say, let p be the quotient of the s, which is s squared plus 2y squared. Let q be the quotient of the y, which is 4 Alright, so you differentiate p partially with respect to y. This will give you 0. This will give you 2. This will give you 4. This time this is 4y, which is 4y. You also differentiate p partially with respect to s. Now there is s, so the power here is 1. So 1 times 4y will give you 4y. 1 minus 1 is s squared. That will give you 4y times 1, which is 4y. So you conclude, since the p partially with respect to y is equal to differentiating p partially with respect to s, which the answer is 4y. It is